Hello and welcome. I'm Josh. This will be a demo video of the Hydra graph language. If you've seen any of my stuff for the last couple of years, you've probably heard of Hydra. It's my latest open source offering coming up on its 1.0 release now, probably within the next few weeks. So I thought this would be a good time to start making some slightly more polished demo videos. This will be the first of a series where I'll probably go into the fundamentals of Hydra, the data model, graph construction in a more formal sense, how transformations work, and so on. But today I wanted to just show you something that's fairly straightforward and useful with Hydra, which is constructing graphs. So if you happen to be at the Knowledge Graph conference last year, you might have seen my presentation on the data model called Lambda Graph, which is based on a correspondence between graphs and lambda calculus. And again, I'll have probably another presentation on that with the demo. You can also check out the source code. There's a Discord server where the most of the discussion is happening. But today let's talk about property graphs. And again, I won't be getting into the details of exactly what property graphs are, but just know there's a formal data model that's defined, which is what we'll be using in the demo. So basic idea of the demo is a very common scenario, which is you have some data and you want to make it into a graph. Often you have some sort of tabular data, some tables with columns, and maybe there are primary key, foreign key relationships. They might be explicit, they might be implicit, but you want to ingest that into a graph. So how do you do that? That's a problem that's as old as graph databases. There are a million solutions for how to map data into a graph. And there are new solutions now, in the presence of LLMs. There are all sorts of ways that you can use LLMs to map data into a graph in kind of a hands-off, code-free way. One of the disadvantages of some of those techniques, like on the one hand, for traditional symbolic mappings, you need a person who understands how to write the mappings and who understands the domain of the data, these tables or whatever they are that you're mapping from. So it's generally a major bottleneck to building knowledge graphs that you have to individually define each of these mappings from your data sources. Like I said, LLMs are kind of changing things. There are, generation-based techniques that can ingest a graph for you. My major concern with most of the techniques that I've seen, used together with techniques like GraphRag, is that is performance, basically. It is very expensive to pass each row of data through an LLM, which is what a lot of these techniques do. So what I'd like to show you in this demo is using an LLM to construct the graph schema, construct the mapping, but from then on, just use the mapping as a traditional symbolic mapping that can really scale without calling back into the LLM. So you train the LLM to create your mapping, and then you're off to the races with that mapping. You can use it in your Spark pipelines or whatever to ingest millions, billions of rows of data efficiently. So I'll be following this demo script, which you can find in the Hydra source under Hydra-ext for extensions. And from there, I'll just jump into it. So let's start by looking at the data that we want to map. Okay, this is similar to what I showed you in that slide. Just some tabular data. In this case, it's some health data. You've got appointments, you got billing information, you have doctors and patients and so on. And there happen to be primary key, foreign key relationships in this. There happens to be a schema that all these rows conform to. Neither of those things is explicit, and that's okay. Our LLM is going to be smart enough to figure those things out. So that's where we're starting from, and we want to get here from here to a graph. So the trick that I'm going to show you is basically to take a second data set, a reference data set, and teach the LLM how to construct a schema, how to construct the mapping. Basically, you need three things. You need to know what the database schema of this thing is. You need to know what is the graph schema that you're going to be mapping into, and you need the actual mapping that takes you from the database schema into the graph schema. So we'll teach the LLM how to do this by giving it a reference data set. This is a sales example. We've got customers and departments and emails and meetings and so on. Very similar format as what we have here for the healthcare, but just a different data set that we can build into this workflow. So let me show you what the schemas and the mappings are going to look like. We have constructed some by hand, so using an expert's knowledge of the DSLs for defining schemas and mappings. Here's a good database schema. It's very simple. It still doesn't have the primary key, foreign key relationships. That's not going to be a problem. It does have a type or a schema for each table, with a number of column types. The column name, the column type, the column name, the column type, and so on and so forth. It's very simple, but it's going to save us a lot of time and also be a lot less error prone if we can get the LLM to do this rather than relying on a human. So the next thing we need, again, is the graph schema. And a graph schema here in Hydra's property graph DSL is just a set of vertex types or node types and a set of edge types. So a vertex type has a label, one label. These are Tinkerpop style property graphs, and it has an ID type, which is kind of like a designated property for identity. And then it may have a number of other properties. They could be required, they could be optional. Each one has a property key or a property name and a type. So you've got the employee vertex type, the department vertex type, and so on and so forth until you get down to edge types. An edge type is very similar, except it connects vertices of one designated label to vertices of one other designated label. And then also has properties. So then the mapping is the most kind of sophisticated of these, maybe the least familiar, but the mapping connects the database schema to the graph schema. So we have for each label of vertex and label of edge that we want to map, we say, okay, where are we getting the data from? Employee data is going to come out of the employees.csv table, and here's how we're going to find the ID for each vertex, and here's how we're going to find the first name property and the last name property. Remember, these three were required. This one is optional, so if there's a value for hire date, we're in the hire date column, then we're going to create a hire date property value. Again, very straightforward. Often these mappings are, extremely simple. There's, a little bit of nuance here in some of these things. I've introduced some helpers just to show that, you can handle a little bit more complexity, but the LLM, mostly I've been using Claude, sometimes ChatGPT, generally don't have any problem with any of this. So that's that. Let's go back to our demo script here. And we're going to create a prompt. So what we're doing is the script is in Python. It's just going to take those health CSVs that we saw, and it's going to create a prompt. So combine the new data that that you want to map into the graph with the canned examples that I just showed you, and create a prompt that's going to help the LLM out. So we'll paste that in, and we can look at what it came up with. So data prompt. And here's what the format of that looks like. It's just some instructions, a fairly short set of instructions for constructing telling the LLM how to construct the database schema, the graph schema, the mapping, and then it's going to give the sample data, just a few lines of each. So here's that sales data that we saw before, and below that, here's the example database schema. Maybe I can scroll a little bit faster, and the graph schema and the mapping that we just looked at, exactly the same thing. So it's just pasting those files into this prompt. And then we're saying, all right, you've seen all that. Now, here's a sample of the new data, the real domain data that I actually want you to map into a graph. So it's going to take a sample of each of those tables and paste that in here. And then with that, the LLM is on its own. I'll go grab the prompt here. That's the prompt that was just generated, and I'm going to go into Claude, and one second, I need to open a new window. And I'll just paste that big prompt in. And Claude is going to start doing things. Depending on what it decides to do first, it's going to start with the database schema. So it's creating what looks like a valid database schema. We can see the same tables that we saw before, so it's creating a schema for each of those tables. The patients table, patients table has patient ID, first name, last name, and so on, and we could go and check those against the actual data, but it's probably correct. Doctors, departments, and so on, and it's already gotten started on the graph schema. So this again is the schema that defines the shape of the graph data that we're going to have in our graph database. And it started by defining some labels, so patient, doctor, department, that all looks reasonable, and then edge labels as well. So primary doctor connects a patient to a doctor supervises, that's probably between a doctor and another doctor, and so on. And then it's going to give us a type for each of these things. So the patient vertex type is going to have this label called patient, and it's going to have some required properties and some optional properties, and so on and so forth down this list of vertex types. And then it gets into edge types. And I don't know why in this case there are no edge properties. Let me go see if I can see that in the data. So like prescriptions, for example. Yeah, so I guess this one just doesn't really have any edge properties. You've got each of these things is kind of a vertex type, and then you just have simple edges between the vertices. So I guess that makes sense. Okay, so the last thing is it's creating a mapping. It's got a helper up here for creating IDs, similar to my helper that I put in the canned example. And then it's creating a mapping. It's saying for patient data, you're going to get all that data out of the patients.csv. And the first name just comes from the first name column, last name comes from last name column. I don't know if it did anything more sophisticated here, like converting between data types or anything. It doesn't look like it. Oh, it's using that label ID helper, so it's constructing these IDs by concatenating different fields. But anyway, then it gets into defining how you derive the edge data. And you'll see some of these table names are repeated. So it's taking the edge data from the same tables as the vertex data. And that's why we don't need edge properties, apparently. So out of the patient's CSV table, it's saying we want a primary doctor edge between the patient, that's represented by the patient ID, and the doctor, that's represented by the doctor ID, and so on down the line. So that has given us each of these artifacts that we need to carry out the mapping. I'm not going to copy and paste these. I'll just use a previous version that was generated a few minutes ago. So that's this. So the database schema, the graph schema, the mappings. And from here, you have your schemas, you have your mappings, and you don't need to talk to the LLM anymore. It's told you everything you need to know about how to map the tabular data into the graph data. And again, you could take this transformation, this mapping here, and use it in Spark or another kind of highly scalable workflow. By the way, there are implementations of Hydra in Java and Python, as well as Haskell, and those will be completely ready to go before the 1.0 release. But let's actually execute this mapping. So if I entered the REPL here, I'll just jump to generating the Copilot graphson, and that's where we'll be generating the actual data we're interested in. That went pretty quick, but it's also not that much data. So that should have been spit out here. This is graphson. This is a Tinkerbop specific, more or less Tinkerbop specific property graph format that puts edge data in line with vertex data, and is just a nice way to import data into Tinkerbop or Tinkerbop compatible tools. So what we did is we took the tabular data, we used the database schema and the graph schema to, together with the mapping, to transform each row of that original data here into either a vertex or an edge, or both. It could be multiple vertices, multiple edges. So I think each of these becomes a single vertex in this case, and some of them also result in edges. And each of those vertices becomes a line in this file. And the final thing we can do, and again, I won't manually import the data, but this is what you end up with. This is g.v, a nice way to visualize property graphs. So it's kind of small, but you can see there are doctors, there are patients, and all of their property data is in here. So this person is named Sarah Johnson, and all this other fake data. And there you have your graph. So again, there are many ways to skin that cat of constructing property graphs based on tabular or other data sources. But I think one thing that's really interesting is trying to combine the best of both worlds of kind of the hands-off, no-code nature of LLM-based techniques, and then the scalability of using a traditional deterministic symbolic mapping, which is what we have here. So hopefully you found that interesting, and I will see you in the next video.